Let's talk about these word problems. So I have a canoeist here, and this canoeist took 2 hours, right, to travel 12 kilometers down the river. When it says down the river has a current, and you're basically going with the current. So the current is helping you. Now, the return trip against the current took 3 hours. So when you're fighting the current, it takes a lot longer. It takes an extra hour. That kind of makes sense, right? The current is helping you in the first situation, and the current is not helping you in the second situation. Now, with this, we have two speeds that we have to think about. What are the two speeds? The two speeds are of the canoeist, and the other speed is of the current itself. In one case, the canoeist and the current are helping each other, and in the other case, the canoeist and the current are fighting each other. So I'm going to draw some arrows to kind of like break this down and what this looks like. So let's say the top arrow, right, is the canoeist, and the bottom arrow is the current. I'm going to call the canoeist, or the paddler, I'm going to call him P. And the current, I'm going to call C. Okay? When I have two arrows kind of going with each other, it means they're helping each other. And the entire trip took 12 kilometers, 2 hours, so the speed is always going to be in kilometers per hour. The speed would be 12 divided by 2, or 6 kilometers per hour. So when they're working with each other, the speed is 6 kilometers per hour. But what about when they're working against each other? It's still a 12-kilometer trip, right? But now the time is a lot different. The time instead of 2 hours is 3 hours. So I said 12 divided by 3. And now if you notice, the speed is a lot less when I'm fighting the current. That kind of makes sense. You're going to be slower, right? Okay. But this is a linear systems problem. How am I going to write a linear system here? What do I do? Well, I can think of these two letters, and I can think of these two arrows. When they are with each other, it's kind of like saying they add together, right? This is kind of what you would see in a physics course. Eventually you'll take physics, maybe, and the two speeds, when the two arrows are in the same direction, they add. P plus C is going to be the total speed when the current is helping you. That's 6. When you're fighting it, it's like saying P minus C because it's fighting you, right? So that's going to be a lot less. That's going to be 4. And so there's my two equations. Amazing. I've got P plus C is 6. P minus C is 4. This is a perfect candidate to do method of elimination. This is where I would do elimination. Okay, so I can just collect like terms this way. I say, okay, P plus P is 2P. C and negative C will eliminate each other. 6 plus 4 is 10. Divide both sides by 2. And I will get P, which is the speed of the paddler. The speed of the paddler, not factoring in the current, is 5 kilometers per hour. That's how fast he's going. So you can think of it as if the paddler was in still water, they would be going at this speed, basically. Okay, so what is the speed of the current? Well, I know that P minus C equals 4, and I know that P is 5. So 5 minus C equals 4. I can pretty much just swap these two. 5 minus 4 equals C. C is going to be 1 kilometer per hour. Amazing. So now I know how fast the current was, or is. The current speed is 1 kilometer per hour. So feel free to write a therefore statement, but the paddler is going at 5 kilometers per hour, and the current is going at 1 kilometer per hour. That's the answer.